All right, so our last standard for quarter one is the normal model. So students will be able to sketch and fully label the normal distribution to summarize data from a population. Students will be able to calculate areas and probabilities using the empirical rule. That's the 68, 95, 99.7, or technology, which is normal CDF on the graphing calculator. And we are going to use normal CDF for all of the questions on a quiz or a test, so that is really the one to practice. However, we still do require that you sketch a normal curve completely, which we will take a peek at. So here's a sample question for Standard 7. Suppose the distribution of weights of puppies is normally distributed, with a mean of 16.3 pounds and a standard deviation of 3.3 pounds. We want to sketch and fully label a normal curve that models this scenario, and then try to answer the questions that follow using normal CDF on your graphing calculator. So if you want to pause the video right now, give this problem a try, and when you're ready, hit play to see the answers. Okay, so first off, here is my fully labeled normal curve sketch. You can see that I've drawn the normal curve and I've written 68% and 95% over the normal curve. So 68% of your data exists within one standard deviation of the mean, and 95% of your data exists within two standard deviations of the mean. Those percentages directly give you the percentages that you see in the normal curve itself. Just doing a little bit of algebra to work those out. Directly below the normal curve, you can see that I have the z-scores ranging from -2 to 2, the percentiles. The percentiles, if you're wondering where those came from, if it's just accumulating the percentages that you see in the normal curve as you move left to right. So the 2.5 means that 2.5% of your data is to the left of that. The 16 is because 16% of your data is to the left of that. And that makes sense because if you look up, you can see the 13.5 plus the 2.5, which gives you 16, and et cetera, et cetera. And then the last row is the x values, which come from the context of the problem itself. I think I added those correctly. The mean of 16.3 goes right down the middle, and then you're adding 3.3 to go to the right. You're subtracting 3.3 to go to the left. And finally, the one thing that you do need to include that I almost forgot was the title for the graph. The title is a capital N, open parentheses, 16.3, comma 3.3. That is just a nice title that tells you everything you need to know about the normal curve in the context of the problem. It is normally distributed with a mean of 16.3 and a standard deviation of 3.3. And that is my fully labeled normal curve. Make sure you practice these. Now let's actually answer the questions. What proportion of puppies oops, little typo there. What proportions of puppies weigh between 13 and 18 pounds? So on my calculator, to get to normal CDF, you are doing second, vars, and then you are looking for the second option down, normal CDF. It's looking for a lower bound and an upper bound. The lower bound is 13 pounds, the upper bound is 18 pounds. Then it wants to know the mean and the standard deviation from the problem, so 16.3 and 3.3. And that gives us a 0.53 as an answer. So what this means in context, 53% of puppies weigh between 13 and 18 pounds. What proportion of puppies weigh more than 16 pounds? Okay, so for this one, same thing, but your lower bound is 16 pounds because we want to know about puppies that weigh 16 pounds or more, right? So the lowest one that we care about is 16 pounds. That's why it's the lower bound. The upper boundary needs to be a really, really, really big number, right? It's technically supposed to be infinity, but we can't quite type in infinity on the graphing calculator. So just a lot of nines will do. I typically type in 8 different nines. So up to you though. Just choose a really, really, really big number. And then the mean and the standard deviation. And it turns out that about 53.6% of puppies weigh more than 16 pounds. And finally, what proportion of puppies weigh less than 20 pounds? So if we're asking about weighing less than 20 pounds, that means that 20 pounds is the largest weight that we care about. So that's why 20 here is your upper boundary. Be very careful of that. Your lower boundary needs to be a really, 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 really negative number. So I just did negative and then 8 different nines. Gigantic negative number. And again, it wants to know the mean and the standard deviation so that it can spit out that 86.9% of puppies weigh less than 20 pounds. And that is standard 7, the normal curve.